Hello, students. So you may remember the factorial function. How it works is you take the numbers from 1 to n and you multiply them together, and that's n factorial. For instance, if we wanted 6 factorial, that would be 1 times 2 times 3 times 4 times 5 times 6. Okay. So how could we do this? Well, there's more than one way we could do this. But notice something, that 6 factorial is just 5 factorial times 6. And 5 factorial is just 4 factorial times 5, right? Because if I take off the 6 here, I'd get 5 factorial, right? And if I had 5 factorial and I take off the 5, I'd get 4 factorial. So basically, we could use 5 factorial to find 6 factorial and 4 factorial to find 5 factorial and so on. So let's try to do that in a Python function. Now, one thing I could do is, let's see, I'll call it factorial. Do I want to call it factorial? I mean, there is a function called factorial. It's not a built-in, it's in the math library. Let's keep it. Let's keep it factorial. Okay, so what we're going to do here is we're going to say, okay, in order to get 6 factorial, you take 5 factorial and you multiply by 6. In order to get 100 factorial, you take 99 factorial and multiply by 100. So in order to get n factorial, we're going to take n minus 1 factorial and multiply by n. Okay. So this is a beautiful, daring idea. It's not going to work. Why did I show it to you if it's not going to work? Why am I wasting your time? Okay. Well, it is going to work, but we need to change it just a little bit. See, the problem here is it's using, say, 5 factorial to get 6 factorial, 4 factorial to get 5 factorial, all the way down. It's using 2 factorial to get 3 factorial, 1 factorial for 2 factorial, 0 factorial for 1 factorial. Then it's going to try to use negative 1 factorial in order to get 0 factorial. I mean, yeah, not good. It's going to go on forever. So I don't want to run this function as is. But what I do know is I do know that 1 factorial is 1, right? Because it's just 1 by itself. So what I'm going to do is I'm going to change this just a little bit. I'm going to have it return 1 if n is equal to 1. Otherwise, I'm going to have it return that. And now, let's see. 2 factorial should be 1 times 2. 3 factorial should be 6. 4 factorial, 1 times 2 times 3 times 4, 24. So what we did here is actually very special. We didn't just have a function that called another function, which is what we were doing a little bit in the last section. We actually have a function that calls itself. Now, if you're not careful when you do this, you're going to get into an infinite situation where Python runs forever, right? Because you're trying to find one value by finding another, and it's just constantly going. So what we need to do is we need to always have what we might call a base case. Like induction needs a base case in mathematics, and we need to have some case where it stops, where it doesn't call itself. Because if it calls itself for every return, then it's just going to call forever. Okay. So what's another situation like this? Well, triangular. So what do I mean by that? Well, let me first say a few words about triangular numbers. So, you can make a triangle. Let's say I put an asterisk and an asterisk and an asterisk and asterisk, asterisk, asterisk. And of course, Python doesn't know that these are comments, so let's do that. Okay, so we can build a nice little pyramid of numbers in a triangle, right? The next one would have 4, the next one would have 5. So a triangular number is one that's equal to the sum of the number of dots in one of these triangles. So for instance, t, I'll just call it t for right now. T of 100 would be 1 plus 2 plus 3, because we'd start from the top of the triangle and we'd keep going all the way up to 100, and then we would stop. By the way, this is the same sum as in the Gauss fable. So that evil school teacher was asking them to find the 100th triangular number T100. Okay, so in any case, how could we do this? Well, let's think about that. In order to get T100, notice that we have T99 right here. So T100 is actually T99 plus 100. And T99 is T98 plus 99. So each triangular number is the previous one plus a number. So let's use that. Return triangular n minus 1 plus n. It's very much like the factorial function. It's the sum version of the factorial function. But as you already hopefully know, we need to have some way of making this stop. So there's a number of things. I could always have it return 1 if n is equal to 1, and that'll work. So now let's try to say, let's get the first 10 positive triangular numbers. So for n in the range from 1 to 11, and these are the triangular numbers. You can see the 6 right here corresponds to our little picture. 1, 2, 3, 4, 5, 6. Now we could always find triangular in other ways too. For instance, if I wanted to make a second way of finding it, I could do that. I could basically return the sum, and I could just make the list of I for I in the range from 1 to n plus 1 because I wanted to include n. As a matter of fact, I don't even need a list here. I can use a generator comprehension. And if I run triangular 2 here, let's do the same thing, triangular 2. Boom, you'll see we get the same numbers. So this is a non-recursive way of doing it, and this is a recursive way of doing it, because whenever we have a function that calls itself, we're going to call that a recursive function. So this has been a tiny little introduction to recursive functions. It's a function that refers to itself in order to get the output, but you can't have it always refer to itself, otherwise it will never stop. Or actually it will stop. Python will give you an error telling you it's gone too deep, and it doesn't think it's doing well at the moment.